Numerical number 5 of the chapter cross product of two vectors. Numerical number 5. OPSQ be a parallelogram and a vector is represented in magnitude and direction by the side OP, and vector B, another vector B is also represented in magnitude and direction by the side OQ, and OS is greater diagonal, longest diagonal, and QP is another diagonal having direction from Q to P, and we can denote the direction of other sides. So the side PS has direction from P to S, and the side Q has the direction from Q to S. According to the question, vector OS equal I cap minus 3j cap plus 4k cap meter, and the expression of and the other diagonal vector QP is equal 3i cap plus j cap plus 2k cap meter. In this case we have to find, and here we can write what the diagonal OS is greater than the diagonal QP. OS is equal to I cap minus 3j cap plus 4k cap, and QP is another diagonal. And in this case we have to find the area of the parallelogram OPSQ equal question mark, where OSQP are the diagonals, two diagonals of the parallelogram OPSQ. OPSQ. Now, using triangle law of vector addition, triangle law of vector addition, in triangle OPS, vector addition in triangle OPS, we get in this diagram using triangle law in vector addition in triangle OPS, the sum of sides taken in the same order, that is vector OP plus vector PS, that is these are two sides taken in the same order of the triangle OPS, is equal to the third side taken in the opposite order, that is OS is the third side which is taken in the opposite order. So now vector OP is vector A is equivalent to, and we know that vector OQ is vector B. So in place of vector OP we can write vector A, and in place of PS, vector PS, we can write vector B, because vector PS is equal to vector OQ, because two sides of a parallelogram are parallel and are same in length. So vector A plus vector B equal, putting the expression of vector OS, that is I cap minus 3j cap plus 4k cap. We get the addition of two vectors, vector A plus vector B, as I cap minus 3j cap plus 4k cap. This is equation 1. Similarly, using the same law, that is triangle law of vector addition in another triangle, that is OQP, using triangle law of vector addition using triangle law of vector addition in triangle OQP. In triangle OQP, here OQ and QP are taken in the same order. The side OQ and QP are taken in the same order. So here using triangle law in the triangle OQP, so two sides OQ and QP are taken in the same order, but the third side OP is taken in the opposite order. Vector OQ plus vector QP, these are the first two sides of this triangle taken in the same order, will be equal to the third side vector OP taken in the opposite order. So that is triangle law of vector addition. We get vector OQ plus vector QP is equal to vector OP. Vector B minus vector B plus vector QP. Vector QP is another diagonal. Vector OP is vector A. So, or comma vector B minus vector A or vector A minus vector B is equal vector QP. Equal vector QP. Or comma vector A minus vector B is equal, now putting the expression of another diagonal, that is 3i cap plus j cap plus 2k cap. Equation 2. Vector A minus vector B is equal 3i cap plus j cap plus 2k cap. Equation 2. Now adding equation 1 with equation 2. Adding equation 1 with equation 2, we get vector A plus vector B, vector A plus vector B plus vector A minus vector B, vector A minus vector B equal I cap minus 3j cap plus 4k cap, I cap minus 3j cap plus 4k cap. Now putting the expression of vector A minus vector B, that is 3i cap plus j cap plus 2k cap. So now it will become, on the left hand side it will become 2 vector A, vector B and minus vector B will cancel out. Then 4i cap minus 4j cap, and it is 6k cap. 4i cap minus 2j cap plus 6k cap. Therefore, we can erase this part, and therefore we get vector A as vector A as 2i cap minus j cap plus 3k cap. This is vector A. Expression of first vector, vector A equal 2i cap minus j cap plus 3k. Now subtracting equation 2 from equation 1, again equation 2 minus equation 1, equation 2 minus equation 1, equation 1 minus equation 2, that is incorrect. We have to remove that part, and also you have to change this language. Here we have to write adding equation 1 with equation 2. Adding equation 1 with equation 2. Equation 1 with equation 2. We get equation 1 with equation 2. We get vector A plus B plus vector A minus B. Similarly, subtracting equation 2 from equation 1. Subtracting equation 2 from equation 1. We get what? Vector A plus vector B vector A plus vector B minus bracket open vector A minus vector B equal I cap minus 3j cap plus 4k cap, I cap minus 3j cap plus 4k cap minus bracket opened 3i cap plus j cap plus 2k cap. Or comma 2 vector B, vector A minus vector A will cancel out. 2 vector B will become minus 2i cap minus 4j cap and 2k cap. Therefore, vector B equal minus I cap dividing all the terms by 2 minus 2j cap plus k cap. This is vector B, which is minus I cap plus minus 2j cap plus k cap. Equation 4. So we get the expression of vector A and vector B. Now we can find vector A cross vector B. Vector A cross vector B equal determinant I cap, j cap, k cap. Then as vector A comes earlier, so you have to put the rectangular components of vector A. That is 2, -1, 3. Then you have to put the rectangular components of vector B. -1, -2, 1. So in this diagram, vector B is derived as 2i cap minus j cap plus 3k cap. So for this parallelogram OPSQ, vector A is 2i cap minus j cap plus 3k cap, and vector B is equal to minus I cap minus 2j cap plus k cap. As in expression vector A cross B, A comes earlier. So putting the rectangular components of vector B, these 2 is from vector A, and -1 is from vector A, and 3 is from vector A. And similarly for vector B, -1 and -2, and with k cap there is only 1, so that's why we have written 1. So if we find vector A cross B, then magnitude of vector A cross B, then we can find the area of the parallelogram. So we can give 3 brackets with I cap, j cap and k cap. So now for I cap, -1 into 1 minus 3 into -2, 3 into -2, 3 into under bracket -2 bracket closed I cap, plus for this rectangular components for j cap, block the column of j cap, and immediate right hand side rectangular component is 3, 3 into -1 minus 2 into 1 j cap. For k cap, block the column of k cap, then 2 into 2, that is immediate right hand side rectangular component of k cap is what? 2. 2 into -2 minus -1 into -1 into k cap. For k cap, we can block this column, then 2 into 2 -2, then -1 into -1. So finally we get what? -1 plus 6 means what? 5, -1 plus 6 I cap, then -3 -2, -3 -2 j cap, under bracket -2 -1 -4 -1 k cap. So we get 5 I cap, vector A cross vector B as vector A cross vector B as 5 I cap minus 5 j cap minus 5 k cap. This is what? Vector A cross vector B. Cross product of two vectors, which is 5 I cap minus 5 j cap minus 5 k cap. Now we can erase this part. Cross product of two vectors is derived. Then magnitude of, therefore, mod vector A cross vector B equal root over 5 square plus under bracket minus 5 square plus under bracket minus 5 square, which is root over 75 minus 5 square, and from k cap, it is minus 5 square. Minus 5. So it will be root over 75. Therefore, mod vector A cross B equal 8 point something. It should be 8 point root over 75 is 8.66. Therefore, the area of the parallelogram OPSQ is 8.66 meter square. 8.66 meter square. This is the area of the parallelogram OPSQ having that two diagonals, vector OS and vector